Next, I'm importing a second library called seed function. Okay, through random method. Okay, and another one is I need to have a randomized weights that has to be allocated for the network. For that also, I'm importing it from the random functions methods. Okay, so these are the basic three functions we need to initialize or we need to import from the particular method. Okay, is it visible? Screen is visible? Hello?
Yes, sir.
Okay. What
Yes,
about the
sir.
rest? Students? Hello?
Yes, sir, it is visible.
Yes, sir.
Okay. So what is the main importance of back propagation algorithm? So we need to
Yes,
decrease
sir.
the errors, right? So let me show you the output first. Okay. So execute it. You'll be getting the output like this. Okay. In the left hand, are you able to see the screen? The console part?
Yes, sir.
Okay. So
Yes, sir.
here you can see here we have generated the weights, randomized weights. I will explain how it is going to generate. Okay. Then we have iterated this back propagation for 20 iterations. Okay, 0 to 19. So that is my 20 iterations. So you can see the L rate. L rate is nothing but my learning rate, which remains a constant. And the error, you can see the error is 6.3 and it's going to decrease till it gets a saturation level. Okay, so this is my overall error. So once I got this, so based on the activation function, I'll be getting the next another weight. Through delta rule, we need to update, right? We have studied it in our back propagation algorithm. So based on that, I'll be getting the weight along with the output for that weight and what is the delta value for the weights. This is the first one. So similarly, as depending upon the weights which is going to be initialized by the system or by the program, that number of iterations it is going to run. So this is your overall output of the lab 4 program. Okay. So let us go with one by one. So first thing is, what is the use of import seed function? So seed is a function which is used in the Python library where whenever I initialize any weight randomly, it has to be the state of that value should be never changed while executing, because once we come out of the program or when you close the program, when you reinitialize and restart the program, at that time the weights may be updated. So to avoid those things concepts, we'll be using the function seed here. Okay, you can get the details how to do the evaluation function for it. Okay. Next, second one is I'm taking the data set of the, suppose here we have taken 10 values or 10 instances. So this is my x1 and this is y1 and what is the target value. So for the first 5, the target functions are zeros, whereas the last 5, the target functions are 1. Okay. So while taking this number of instances, the iteration goes more. Okay. So the assignment will be given based upon the try to don't take these values after the decimal point. Okay. And take only the first iteration and the last instances for tracing purpose. Okay. Because tracing takes so much of time. So try to do that and that will be your assignment for the lab. Okay. Next, once I got this data, so what I should do, I need to get the number of inputs to the neural network, right? So I'll be getting it from number of input equal to length of the data set minus 1. So what is the length of the data set? Vinuta? You need to be more interactive because this program takes so much time. Be fast while whenever I ask a question, try to answer it. Okay. Vignesh?
Yes, sir.
Srinivas? What is the length of this data set? Lucky? Hello. Okay. The length of the data set. So we are considering the data set of the instance of first row. So this part. So I am having three values here. So data set of 0 is 3. So 3 minus 1 is 2. So the length of the number of input will be 2. Similarly, I want to find out the number of output. So to find out the number of output, length of the set function using row of minus 1. So this row of minus 1 gives the last value in the data set. So that is 0. So I need to create a network. So as we are having 2 cross 2, so you'll be getting the number of edges as 2 power 2. Okay. But initially this is with respect to network, whereas now we need to generate the edges. So to generate the edges to connect between those two units, so I'll be calling the network function. Initialize the network through number of inputs, that is 2, and this 2 is my hidden unit, and this is the number of output. So function of input is 2 plus 1, so 3. The range is 3 means the iteration of this loop runs 3 times. Okay, for 0, 1 and 2. Okay, so that is my first part. So next, once I got the value, next I will be updating the hidden layer range. So the number of hidden is 2, so it will be appended by 2 edges. Okay, so first instances to the next first hidden layer, first instance of the node to the second hidden layer part. Okay, similarly these things will be appended to the output layer from hidden layer. So to get that, I'll be calling output layer. So this is the first part and this is the second part. Output layer equal to now weight into random for I in range. So hidden is 2 plus 1, so 3. So it will be iterated through 3 times and we will be getting the number of edges. So once I got the edges, and I'll be appending the network to the output layer from hidden layer. So I will be calling the network now. So what is the network value? I click on here, click enter. So this is my network value. As iteration has taken for 3 times, from totally 3 into 3, 6 times. So you will be getting first weight. So this is my first weight. This is my second weight. This is my third weight. Okay. So, and this is the overall output. Okay. Because I have not yet called the seed function. So it is giving like this. Okay. Before that, we need to call the seed function. Okay. Go in the order of the iteration how to do that. Okay. And call network. You can see here. So this is the actual network which is being generated by the program. Okay. Next, once I got that value, so what I will do, I'll return that network to the system. So I have called the edges and this data comes over here. I'm going to print that network. So this is my actual network. So for the overall network, what are the weights? So as we are having two hidden input units, 2 hidden units and 2 output units, what is the total number of edges? 2 plus 4 plus 4, 8. So 8 plus 2, 10 plus output 2. Input is 2. In the intermediate network, I'll be having 4 edges. In the next layer, I'm having 4 edges. In the output side, you'll be having 2 edges. So total weight of 14 weights, 12 weights will be generated. So 1, 2, 3. So second weight 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So this is my actual network value. So once it is done, so I need to train the network. So train the network using the network, given network. So what is the data set that I'm having? Then what is the learning rate? So the learning rate is 0.5 and how many times I need to run it. So I have taken 20. So this is my epoch value. Okay, and what is the number of outputs? I'm having it as 2. So what happens now? This is a function. So it comes over here to the train network. So network, the arguments will be taken from the function call. So for each epoch in range, so the number of epoch is 20. Any doubt in this initialized network? Did you got it? This part. Initialize the network. So number of input, hidden units and output units. So I'll be generating the weights from input to the hidden layer. So I'll be getting 6 weights. Okay. Next, in the output layer, I'll be getting 6 weights. So total 12 weights will be updated in this function. So that will be called back to the network here. It will be printed, and then I'll be calling the network function, train network. So this is my train network function. So it has to be iterated based on the number of epoch value that is given is 20. So initially the error will be 0 because system doesn't know anything. So it will be 0. So for each row in the training data set, so what is the training data set? This part. Okay, so for each row, I need to calculate the error. Okay, so for that, I'll be calling the output function to get the output. What is the actual error that has to be passed to the output end? So for that, I'll be because we have not yet trained right initially. So the first training is my forward propagation. Before I go to the backward propagation, I need to train the values to the forward propagation. So this is a function forward propagation. So what is the arguments? Network and row. So this row is nothing but your dataset values. Okay. So once I call this function forward propagate, so this is my function definition of the forward propagate. So I am considering the row, whatever the dataset that comes to the function as inputs. Then for each layer in my network, I'll be calling the inputs. So because initially the inputs are not yet have been initialized. So I've been calling a list, empty list to be initialized to new input to all the layers. Okay. So for each neuron, for each node in my layer 0 and 1, or as we are having 2 layers here. So what is the activation function? So activation function is given by activate. So where we need to activate the content in the neuron part. So neuron of weights, comma input. So this is function activate, which is given here. So what I will do, I will be getting the activation function. How to get the activation function? I need to calculate the weight of from the weights. So weights of -1. As we are in the first layer, first iteration. So I'll be getting what is the meaning of this content weight of -1 means this part. In Python, what is the use of this? What is the value that's going to be returned over here?
Sir, from last first one. Sir, from last first one, sir.
Last in the first one. Okay. So in the weights, you can see here in the right hand side, we are having generation, number of weights that has been generated. So in the first iteration means this part. So in this weight, I need to get the last one. So that is my 0.763. Okay. So this will be the weight which will be called for the activation function first value. Then what I need to do, I need to get the activation function for all the weights. So for that purpose, so this acts like your W0. Okay. Whereas the first and second one acts like W1 and W2, because we know the formula in backpropagation equal to W0 plus W1 x1 plus W2 x2. Okay. So for I in range, the length of the weight, what is the length of the weight? It is 3. So 3 minus 1, 2. So the range 2 means the values are 0 and 1. So it will be executed 2 times. So for 0th iteration, activation equal to, this is a shorthand assignment operator, activation plus, or activation equal to activation plus weight of I into input of I. So activation value is 0.763 plus what is the weight of I? As the value if I is 0, weight of I means this part. This is my first weight. So that is 0.134 into what is the actual input? Input is nothing but my data value. So that is the first row, this one. So in the input, the index 0 means this part. So 2.7810. So these values will be executed in the activation function. Once I get the value, as the execution is not yet been ended, so you'll be getting a new weight from the first 0th iteration. Next, the range function or the for loop runs for another time because the range has not yet been executed completely. So it will be updated to 1. So the weight, that is activation function, that is going to be getting new activation function, update to the next weight. So the I value becomes 1. So weight of 1 means the second weight in the iteration. So that is my 0.847. And input of I means that is my second input. So this part 2.55. So once you get that value, so you'll be getting the activation function, and this for loop gets completely executed. So I'll be calling that activation function to the network. So where it is going to be executed, it comes back to the forward propagation because we have called over here. So that value will be taken as activation value. Then I need to send that data to the output end. To send that value, I'll be calling a variable neuron output. So I'll be calling the transfer function now. So what is the transfer function? It's a transfer function is nothing but my sigmoid function value. So transfer function is written over here, which is given by return into 1 divided by 1 plus exponent of minus activation value. So this is my x value according to the algorithm. Okay. So that is going to be executed and you'll be getting a value. That value will be sent as or stored as output for the neuron. Then I will append that output to the next input, that is going to be where it has to be sent. So that is your new input dot append. Okay. Next, I'll be calling the new input functions because already I have got the first value. Similarly, as this, the layer is only been executed for first iteration. So this iteration takes place for the remaining 4 iterations: weight of 0, weight 1, weight 2, and weight 3. Okay, it will be updated for the 4 overall 12 weights, 2 plus 2 layers. Okay, you'll be getting the activation output value. Okay, so that value will be sent back to the function where we had called this in the train network here. So I have got the actual output. Now what I should do, I should call the expected value. So I need to get the expected. What is my expectation? As the target values are 0 and 1, you have to get the expected value as 0 and 1. So to get that value, I'll be calling expected equal to 0 for I in range, the number of output. What is the number of output? 2. So range of 2 means 0 and 1. So for each 2 expected values, I am initializing it into 0 initially. Then once I got that values which has been initialized, so what I will do, I will get the last value of the expected row because that is my target function. So I'll be calling that value as it is 0 and 0. So row of -1 is, so row of -1 means this value. This is my actual row. So it is also 0. So the expected value for the data will be expected of 0 equal to 1. So what will be the list? The list will be 1, 0. Initially it was 0, 0. Now it will be updated to 1, 0. Okay. And if you are having any doubts to get the value, iterate the process how we are executing, call the respective variables and post it over here in the console so that you'll be getting the actual values. Okay. So by doing that, you can get the exact memory values that are going to be inserted to the system, or for the training, you can get it. And once I got that value, so I need to evaluate what is the overall error for the propagation, forward propagation. So that will be called by sum error plus equal to sum of expected I. So expected value is, that is my 0th index. What will be the value? 1. So we know the formula 1 minus output of I whole square. So this is my expected output, and the actual output that I have got, power 2. We have solved it in the one problem, right? Like it's a multiplication of 6. One program we had did it where we have solved the problem and the theorem regarding the backpropagation algorithm, how to get the sum error or what is the loss function. Okay, so once I got the data, so what I will do, I will call the range function. So the length of expected is 2, so it is going to iterate it 2 times. So once I have got the data through forward propagation, there will be some errors, okay, which will be having high error value. So what I should do now, I need to randomize, change my weights in different layers, and I need to go for backward direction to modify those weights. So for that purpose, I'll be calling the backward propagation function. So backward propagate error of network comma expected. As the expected values are 1 and 0, I'll be training the network. So once I call this backward propagation, it comes to the function. So what I will do, the length of the network I will be getting, so it is as 2, and the range of 2 means 0 and 1. So it will be called, so I'll be taking the first network, so that is my first from input to the hidden part. So this is my first layer, and the second layer is from hidden to output unit. Okay, so I'm calling an empty list for the errors. I'll be checking if I not equal to length of network minus 1. So the length of network is 2, 2 minus 1, 1. I value is 0, so 0 not equal to 1, true. So it goes for the next iteration. So for j in range, the length of the layer. So the length of the layer is also 2. So j is 0. Now for the first value, I'll be calling the error as 0 for backward propagation, because we don't know what is the actual error. So initially I'm giving it as 0. For neuron in the network, for the first one, 0 plus 1, that's my first network. So error plus equal to neuron of weight into j. So weight I'll be getting from this table. As it's a list, it's going to get all the weights in the iterations, and I'll be calling the delta value from the neuron. So that is my sigmoid function value. So I will calculate the error, append that error. So this is my, you can see here in the output end, see here one, this is my actual error in the first iteration. The error is 6.350. Okay, similarly it will be iterated many times, and the second iteration it gets reduced to 5.5, next 5.2. okay, so these values will be updated for all the iterations whenever this condition is true. Suppose now the value of I gets updated to 1, so 1 not equal to minus 1, so this condition becomes false, so it goes for the else part. In the else part, I will be calling the j in range. The length of layer is 2, so it will be iterated for 2 times, and it will append the expected value to the output neuron. So it will be subtracted. Expected of the data, that is my j value, 0, that is my 1 minus neuron of the output, that whatever I got in the activation function. So whenever I do that, so I'll be getting the actual error. Okay, this part executes completely. Then the last remaining part is I need to update the derivation for the neuron. So that's my, I need to update the delta value. So what I will do, I will call another delta variable equal to error of j. So j is 0 into transfer of derivative. So this is a function. So why we need transfer derivative? Because we need to subtract the actual output from the obtained output. So that is, this is a function call. So it comes to this part. So I'll be returning the output into 1 minus actual output. Okay, I'll be getting the value as point something value. So 1 minus particular that value, you'll be getting these values. Okay. So once I get this value, what I will do, I will call back this data to the backward propagation in the training system. So it comes back to here. Then I will update the weight. So to update the weight, what are the things I require? What is the actual network? What are the number of rows? That is my data set. What is the learning rate? So we have initialized those values. It will be getting from these arguments. So update weight is a function where we need to update the through backward propagation. So I'll be calling the range. The length of network is 2. So for 2 iterations, it's going to execute. So what is the input? I need to get the data from all the values in the data set, excluding the -1. You know, row of list colon -1 means it's going to take the input from the initialized network to the last, excluding the last value. So it considers this x1, y1, excludes the target function values for the overall data set. Okay, then once I got this overall network values, okay, as inputs, so what it takes, it checks for each condition. If I equal to 0, 0 not equal to 0, false. So it goes for next for neuron in network of j. So initial weight will be equal to weight of j plus learning rate into neuron of the delta value which has been obtained into input. So input is my data value. This is the first 0th value. Okay. Once it gets to updated for 1, j becomes 1, it considers this value. Okay. So this part iterates 2 times, and I'll be updating the total weight by the formula neuron of weight of -1, because I need to subtract the weight. So equal to learning rate into neuron delta value. Okay, this will be iterated for overall network, and then I'm printing the respective epoch iterations values. Okay, then what is the learning rate, then what is the actual error, and what is the epoch that is being executed with respect to learning rate, and what is the actual sum of the errors that has given for the training network. So you can see in the console screen, the error gets decreased at each iterations. Okay, once it gets at the 19th iteration, and it need not to be, you can take 20 here in the call function call. Okay, try to go with least numbers first, 5, 10, like that, until you get the saturation level where the error doesn't exceeds that value. Okay, or decreases from that value. Till that iterations you need to execute. Okay, so this is your 4 lab program. Okay, so try to get the values. Okay, by solving only 2 values, try to get in the data instances first and last instances, because the target values are different. Okay, so you'll be getting the output. Try to do this. Okay, that will be your assignment for the lab. Okay, so this is using the concept of your lab program, backpropagation algorithm. Okay, there's another program where we have the second method. This is also simpler one, but here we are going to take like this. Instead of this, we're calling. So this is nothing but we are taken an array of numpy datas. Okay, where it depends upon the 2 cases. Based on during exam time, the number of sleep depends upon the number of study. If you are sleeping very less time, the output result will be more, so that you will get a best results in the exam. So this is the values that has been trained. So for I'll be getting the x value as the maximum value from the x-axis. Then I need to divide it by 100 because the values are more than 0 and 1. So what I should do for the sigmoid function, I need to get the values from 0 and 1. So I'll be taking the value of y as 92, means 92 divided by 100 means I'll be getting 0.92. Okay, so these values will be generated for all the inputs x and y. Then I'll be calling the sigmoid function as what we have seen in the earlier, same thing, return 1 divided by 1 plus np into exponent of minus x. Next, sigmoid function, derivative sigmoid function is nothing but x into 1 minus x. And initialize the variables. We have given it values. You can, no need to have 5000. Try to go for 20 iterations first and then increase it. Okay. So we have taken the learning rate as 0.1. What is the number of input neurons? 2. Hidden layer neurons are 3. And what is the actual output neuron? So I need to get only the output as either 1 or as the best part, because we have taken the data set as assuming that exam case study. So this will be an actual only one output, whether you'll be getting a good result or not. Okay. So once I got this, initialize the values. So I'll be calling the weight of the hidden unit. So weight of the hidden unit will be given by np, that is my numpy variable, into random dot uniform of what is the size. It depends upon the number of input layer neurons and the hidden layer neurons. Similarly, I need to bias. So this is bias is nothing but for the hidden layer. I need to update the weights. So that part is given by np dot random dot uniform of size equal to 1 comma hidden layer of neuron. So similarly, this is for weight for hidden layers. Similarly, I need to calculate the output weights. The same thing it retains except the input values. So here we are taking input layer neurons. Whenever we are considering output, the weight will be carried from output to hidden layer to output neuron. Then similarly for biasing the output values. So I'll be calling the range function through epochs. So hidden input weight, then it will be biased, and hidden layers through sigmoid function, output input, and what is the actual output which has to be made as input to the next hidden layer. Next, what is the actual overall output through sigmoid function. Then backpropagation will be called. Okay. Then what is the error? What is the out gradient of the derivative of the output error? So I need to get it to be reduced. So I'll be calling the outgrad function. Then I'll be getting the error for the hidden units. This is for hidden error for the output. This is for the error for hidden. And what is the actual derivative for the hidden layer? And what is the hidden layer's expected value, error through hidden then the overall weight into the actual input into hidden layer, what is the actual learning rate in the hidden layer. So two weights will be updated. One is from input to hidden and the second one is from hidden to output end. So that things will be executed, and then I'll be printing the what is the actual input, what is the actual output, what is the predicted output. So when I execute it, you can see here WH plus. Okay. So you can see here, I got the input. Input as 0.661, 0.33, 0.55, 1 and 0.66. So this is my actual input. What's the actual output? I told you it will be divided by 100. So 0.92, 0.86, 0.89. Then what is the actual predicted output for the given input? So this is my percentage. What is the actual percentage they're going to get passed in the exam? Okay, this is a simpler one. Okay, you can use either this program or the earlier program. Okay, whichever is easy for you, you can learn that one. Okay, the concept remains same. Whatever we discussed in the earlier part, it remains same, except we have taken your data set as exam data set, like 2 hours of sleep and 9 hours of study. So gives highest result. Okay, so similarly, we have taken the different type of data. Okay. So try to trace the values for 2 iterations of different target functions. Okay, you'll be getting how to train that value. Suppose if you don't know how to get that value, go to your spider pipe IDE. There you can run the program line by line. Okay, from the seed part till the error function. Okay, try to give the values in the console screen, execute it, so you'll be getting the actual values. Okay, if you want to debug, you know how to do the debugging part in Python. Okay, so try to go by step into line by line execution, see the values that is going to be assigned in the for the respective variables. Okay, so this is your 4th lab program. Okay, any doubts in this? Do you have any doubt? This will be easy for to study, but actually the earlier program what we studied, that will be best, I think, because based on the function you have studied into lab in your textbook, it resembles as it is. Okay, if you have any doubts, you can ask me now.